Welcome to Grade 11 Chemistry, Periodic Trend in Properties of Elements Valency. You have learned in the previous video that valency is determined by number of valence electrons present in the outermost shell of an atom. If you look at modern periodic table, there are 18 groups. The vertical columns are called groups and 7 periods. The horizontal rows are called period. The group 1 and group 2 elements are known as S block elements, and group 13 to group 18 elements are called P block elements. The S block and P block elements are together known as representative elements or main groups elements. The valency of representative elements is equal to number of electrons in the outermost shell or 8 minus number of electrons in the outermost shell. For group 1 elements, which include hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, they have the outer electronic configuration NS1. As there is only one electron in the outer shell, the valency is 1. Group 2 elements beryllium, magnesium, calcium, strontium, barium and iridium, they have the outer electronic configuration NS2 and they have only 2 electrons in the outermost shell, so valency is 2. Group 13 elements boron, aluminium, gallium, indium and thallium, their general electronic configuration is NS2 NP1. As they have 3 electrons in the outer shell, the valency is 3. Group 14 elements carbon, silicon, germanium, tin and lead, their general electronic configuration is NS2 NP2. As they have 4 electrons in the outer shell, their valency is 4. Group 15 elements nitrogen, phosphorus, arsenic, antimony and bismuth, their general electronic configuration is NS2 NP3. They have 5 electrons in the outer shell, but their valency is 3 because it is easier for these elements to gain 8 electrons in the outermost shell by sharing 3 electrons from other elements. So valency is 3, 8 minus 5. Group 16 elements, which include oxygen, sulfur, selenium, tellurium and polonium, their general electronic configuration is NS2 NP4. They have 6 electrons in the outermost shell. It is easier for them to gain 8 electrons in the outermost shell by sharing 2 electrons from other shells. So valency is 2, that is 8 minus 6. Group 17 elements, which include fluorine, chlorine, bromine, iodine and astatine, their general electronic configuration is NS2 NP5. As they have 7 electrons in the outermost shell, it is easier for them to gain 8 electrons in the outermost shell by sharing 1 more electrons from other elements. So valency is 1, it is 8 minus 7. Then comes group 18 elements, which include helium, neon, argon, krypton, xenon and radon. Their electronic configuration is NS2 NP6. They have 8 electrons in the outermost shell and the valency is 0. It is 8 minus 8. If you observe the valency of these elements, representative elements, along a period from group 1 to group 18, you will see a trend in their property. The valency increases from 1, reaches a maximum value 4 at group 14 and then decreases to 0 at group 18. Now let us discuss how the valency changes in a group elements. For example, group 1 elements hydrogen, lithium, sodium, potassium. Here we can see the electronic configuration of all these elements. They have only 1 electron in the outermost shell. So in a group, the valency always remains the same. Whereas in the period from left to right, valency increases from 1 to 4 and then decreases to 0.